From the information that math dude provided, students completed a table. So on day 0, the initial amount was 1 penny, and then he doubled it every day for 1 month, the amount from the previous day. So on day 1 it was 2 pennies, day 2 was 4 pennies, day 3 was 8 pennies, and so on. And then we plotted it on the graph, and students did see the curve, that it was increasing rapidly, and they knew it was curving in that first quadrant. They may not have known that it curved down close to the x-axis, but not crossing the x-axis because they're not familiar with the horizontal asymptote yet. But they could see that it was increasing rapidly. And plus from the table they could see, when we looked at it, I asked, is it linear? Well, it doesn't look linear on the graph because it's curving and increasing rapidly. And then if you look at the t-table, it also has, if you subtract previous values, 2 minus 1 would be 1, 4 minus 2 would be 2, 8 minus 4 would be 4, and 16 minus 8 would be 8. You can see that it's not increasing at a constant rate. So we tried something else and looked at the output and said, well, what is happening with the output? Well, when you look at the output, you have 1, 2, 4, 8, 16. Well, it's doubling. Well, what does it mean to double? It means to multiply times 2. And so you're multiplying by times 2 on each of the output. Times 2, times 2. And so how do you write that equation? Now, a lot of students wanted to write y equals 2 times x, but we've talked about x to the first power is linear, and this graph is not linear, it's not looking linear, and plus it's not linear from the rate of change, it's not constant. So how would you write this? Students know that the doubling means that there's 2 in the equation. Well, what else do you notice about the values? 1, 2, 4, 8, 16. How do you get those values in the equation with 2 being in the equation? Well, it's the exponent. And so where would you put the variable for x? Where would the input go to create these output values? And so it would be 2 to the x power. And it takes some questioning, and because doubling, they want to multiply just times the 2. But then they realize that the output's the only thing being multiplied times the 2, and that's the common ratio that we'll talk about later when I give them notes on the equation. But when we check the table, 2 to the first power, or 2 to the 0 power, they may not know 2 to the 0 power yet because we haven't studied exponents unless they remember it previously is 1. So we check the other values. 2 to the first would be 2. 2 to the second would be 4. 2 to the third would be 8, and so on. And so they do realize that it's 2 to the x power, which is an exponential growth. And the next day we'll look at an example of exponential decay.